Yes, friends, welcome once again to the class and welcome once again to another lecture of nuclear and particle physics. And we are continuing with our nuclear shell model, about which some of the facts I had already told to you in the previous lecture itself. So, we are continuing with that. So, nuclear shell model is the simplest nuclear model which is explained by quantum mechanics. You have already learned this. I have already told to you that nuclear shell model is based on quantum mechanics, and it is an attempt to explain the extra stability of magic nuclei. Okay, and how it is an attempt to explain the extra stability of magic nuclei, also regarding that I have already told to you. Okay, because whenever magic nuclei is encountered, that is whenever magic number is encountered, the nucleons, the nuclear shells are completely filled in that particular case whenever magic number is encountered. So magic number, whenever it is encountered, the nuclear shells are completely filled. So that's why it is an attempt to explain the extra stability of magic nuclei, and it helps to predict the ground state, spin, parity, magnetic moment of large number of nuclei. Okay, so the success of nuclear shell model is that for large number of nuclei it is able to predict the ground state, spin, parity, magnetic moment, and that too for large number of nuclei. Okay, so the assumptions of this particular nuclear shell model is that we are assuming it to be single particle model. Now what is single particle model? I have already told to you that the nuclear force, the central nuclear force which is acting on the nucleon, we are assuming it to be because of the other a-1 nucleon. Suppose we have a nucleons in the nucleus. I had already told to you in the previous lecture. Suppose we have a nucleons in the nucleus, then what will happen? Instead of a, suppose a is equal to 5, suppose, then what will happen? Then suppose this is the nucleus, this is the boundary of the nucleus, and inside this nucleus there are various shells in which the nucleons are revolving around the center of nucleus. Now if we have 5 nucleons, so suppose we have 2 protons and 3 neutrons, suppose. Okay, so 2 protons are over here and 3 neutrons are over here. Let us assume like this. Let us assume the situation to be like this. Then what will happen? The nuclear central force, which will be acting on each nucleon towards the center of the nucleus, that particular nuclear central force will be the result of, suppose we consider this particular nucleon, then what will happen on this nucleon? The force will be because of these 4 nucleons. Okay, and if we talk about this nucleon, then the force will be, then the central potential developed will be on account of the other 4 nucleons. If we consider this particular nucleon, then the nuclear central force will be on account of the other 4 nucleons. So similarly, in that fashion, if we have a nucleons, then the central nuclear force which is being developed, that is the central potential which is being developed, the central potential which is being developed will be because of the a-1 other nucleons. Okay, so that is the thing. Each nucleon moves independently inside the nucleus under the effect of net central potential V of R. So each nucleon is moving independently inside the nucleus. The motion of one nucleon does not affect another nucleon. That is what we are assuming over here, that the way one nucleon is moving, that does not affect the movement of another nucleon. Okay, I am not talking about MOMENT moment. Okay, I am talking about movement. Okay, so the movement of one nucleon will not be affected by the movement of another nucleon. Such is the assumption of single particle model. Okay, so that is the thing. And movement, MOMENT movement is different and MOVEMENT is different. Okay, so do not get confused between them. MOMENT movement is such as nuclear magnetic moment and etc. Those are MOMENT moment. Okay, but MOVEMENT means to move. Okay, that is the motion. We are talking about the motion. So the motion of any nucleon is independent of the other a-1 nucleons, but that is the motion of each nucleon is independent of other a-1 nucleons, but how the other a-1 nucleons are moving, that does not affect the way this nucleon will revolve around the center of nucleus. That is the assumption of single particle model. For more details, you should go to the previous lecture. I have discussed all these concepts in detail in the previous lecture. Okay, so each nucleon moves independently inside the nucleus under the effect of net central potential V of r. I have already discussed, right? Or central attractive force. Central attractive force produced by the average interaction between remaining a minus 1 nucleons. Okay, so the central attractive force produced by the average interaction between other a minus 1 nucleons, that is the reason why this particular nucleon is moving. Okay, but the way other a minus 1 nucleons are moving, that does not affect the way this nucleon will move. Okay, although the central potential is being provided by other a minus 1 nucleons, but the central potential will not differ depending on how other a minus 1 nucleons are moving. That is the meaning. Okay, so the movement of other a minus 1 nucleons is independent of the movement of this nucleon, but the central potential is being provided, central nuclear potential field. Okay, central nuclear force potential, that is being provided by the other a minus 1 nucleons in the nucleus. Okay, it is possible to describe the central field as short range potential well. Now how can you describe the central field? It is possible to describe it as short range potential well whose exact nature is not known. Okay, so the central force which is being acted over here, the central potential V of r which is being acted over here, okay, we are talking about short range potential well. Okay, the central force will be short range potential well, means this central force will be of short range whose exact nature, the exact nature of this central force which is acting on the nucleons, that exact nature is not known, but we are assuming it to be central force over here. Okay, and what type of central force? The central force is because of nuclear force. The central force which is acting on the nucleons is because of nuclear force acting between the other a minus 1 nucleons and this particular nucleon. So the central force will be on account of the nuclear force, and as that will be on account of nuclear force, so that's why that is short range potential well. Okay, because nuclear force is a short range force, not a long range force, so that's why it is short range potential well. I had already discussed these things, I am just revising the concepts once again. Okay, in this central potential field, each nucleon is supposed to move in a shell. And what is the characteristics of this central potential field? Each nucleon is supposed to move in a shell depending on its energy and angular momentum in a manner analogous to atomic electrons. What do you have in atomic electrons? In atomic electrons, you have various shells, first shell, second shell, third shell, okay, K shell, L shell, K shell, L shell, M shell, N shell, okay, KLMN, like that. You have the shells, and the principal quantum number n is equal to 1 for the K shell, n is equal to 2 for the L shell. As you move away from the nucleus, the electrons are getting in the higher energy level. Okay, as you move away from the nucleus of the atom. That is the case with atoms. But with nucleus, similar is the situation which we have. So each nucleon will be filled in which shell? Each nucleon will be filled in which shell, that depends on its energy and angular momentum. Okay, so in case of atomic electrons also, while writing the electronic configuration of elements in the lower classes, or if you had chemistry in BSc along with physics, then you must have learnt one thing over there, that while we are writing the electronic configuration of elements, we are filling the electrons in a similar manner. Depending on energy and angular momentum, we are filling up the electrons. Okay, so similarly the nucleons will be filled in various shells depending on their energy and angular momentum. Okay, as nucleons are fermions, okay, you know this very well, that nucleons means protons and neutrons, and protons and neutrons are what? Fermions. Okay, they are not bosons, they are fermions. So protons and neutrons are fermions, and I had already told you the difference between fermions and bosons in the previous lecture. Okay, previous lectures, I don't know whether I taught it 2 lectures before or 3 lectures before or 1 lecture before. I am not remembering it properly, but I have taught you the difference between fermions and bosons. Okay, so the nucleons are fermions, so no two of the nucleons can be in the same quantum state. This is similar to Pauli's exclusion principle. Okay, this is similar to what? This is similar to Pauli's exclusion principle. Now what is Pauli's exclusion principle? You have already learnt it in the lower classes. Okay, that no two electrons can have the same, all the 4 quantum numbers as same. Okay, I am giving you the analogy with electrons. Although we have nothing to deal with electrons because we are learning physics, we have to deal with neutrons and protons, not electrons. But in chemistry, in lower classes, we have learnt about Pauli's exclusion principle. What does it mean by Pauli's exclusion principle? Let us see. Suppose we have this particular, suppose we have this particular shell. Okay, electronic shell I am talking about. I am talking about electronic shell, not nuclear shell. Okay, 1 2 3 4 5. Then what will happen? Suppose this is suppose dxy. Okay, this is suppose dyz. This is suppose dzx. This is suppose dx square minus y square, and this is suppose dz square. Okay, so we have this is 0, this is plus 1, this is plus 2. Okay, this is minus 1, this is minus 2. This is what? This is your ml values. Okay, ml values. And as the subshell is d, so the value of l is equal to, for s we have l equal to 0, for p we have l equal to 1, so for d we will have l equal to 2. Okay, so this is the value of l is equal to 2 for this particular subshell. And suppose we are talking about 3D subshell in the electron, then what is the value of n? N is equal to 3, which we have with us. Okay, now the fourth quantum number. Now when I am trying to fill up electrons, I cannot fill up the electrons like this. Why I cannot fill up electrons like this? Because in that case, all the electrons will have this. Okay, the two electrons, when we try to write the spin quantum number, then it will be either plus half or minus half. But if we are writing the same directions, we are giving the same direction of arrow, that means they have similar spin, and similar spin means that is not possible according to Pauli's exclusion principle. So according to Pauli's exclusion principle, this particular electron will be filled like this. Okay, so that the ms value is different, that is equal to minus half, that is opposite spin. Okay, so now the four quantum numbers are different. For the electron like this, for the electron with upward spin, we have the quantum number equal to n equal to 3, l equal to 2, ml equal to minus 2. Okay, and ms equal to plus half for this upward spin particle, electron I mean. And for the downward spin electron, we have all these are same for the downward spin electron, but ms will be equal to minus half. So no two electrons can have all the four quantum numbers same, that is n, l, ml and ms. No two electrons can have all these quantum numbers to be same. Okay, if you are encountering an electron with both the quantum numbers as all the four quantum numbers as same, then you will have to make the electron of opposite spin. Okay, so that the fourth quantum number is different. So that's why no two electrons can be filled like this, or no two or three electrons cannot reside. That's why. Okay, you cannot do like this. Okay, because in this case all the four electrons will have the same quantum number. Okay, so you have to fill it like this. That is what is the meaning of Pauli's exclusion principle. Even if you don't understand what is Pauli's exclusion principle, that is not the matter. Okay, but I just made you revise. Okay, I just made you revise all the concepts. So as nucleons are fermions, so no two of them can be in the same quantum state, because the rule which fermions follow. Okay, which rule do fermions follow? Fermions follow the Pauli's exclusion principle. Okay, fermions follow the Pauli's exclusion principle. So as fermions follow the Pauli's exclusion principle, so no two of them, no two nucleons, that is protons or neutrons, no two of them can be in the same quantum state. Okay, that is the meaning. The energy of a nucleon energy level depends on the quantum numbers n, l and ms. Okay, so energy of a nucleon energy level depends on the quantum numbers n, l and ms. Okay, so n is principal quantum number, n is what? Principal quantum number, l is what? Azimuthal quantum number, and ms is spin quantum number. Okay, so the energy of each nucleon will depend on principal quantum number, azimuthal quantum number, and your spin quantum number, and they will obey exclusion principle, that is Pauli's exclusion principle. Each energy level occupies a maximum of 2 into 2l plus 1 neutrons or protons. Okay, so in the case of electrons, what did we have? The formula in case of electrons, maximum number of electrons which can be filled in a particular shell. Okay, this is what? 2n square. Maximum number of nucleons. 2n square is what? Maximum number of nucleons which can be filled. Okay, which can be filled in a shell. So 2n square is the maximum number of not nucleons, that is electrons. Okay, 2n square is what? Maximum number of electrons which can be filled. Okay, 2n square is what? Maximum number of electrons that can be filled in a shell. But in case of nucleons, the dependence is not on n. Okay, in case of nucleons, in case of electrons, the dependence was on n, that is principal quantum number. But in case of nucleons, that is protons or neutrons, the dependence will be on L, and the maximum number of nucleons which can be filled, that is given by 2 into 2l plus 1 instead of 2n square, which was the case with electrons. Okay, so you must remember this. Mayer and Jensen proposed that each nucleon in a nucleus feels in addition to net nuclear potential a strong inverted spin orbit coupling between nucleons. Okay, so the Mayer and Jensen, they have proposed that each nucleon in a nucleus, the nucleons which we have in the nucleus, they no doubt feel the nuclear potential because of nuclear force. In addition to that, they also feel a strong inverted spin orbit coupling. Okay, now what is this spin orbit coupling? That will be even more clear to you when you learn the atomic and molecular physics. Their spin orbit coupling will be even more clearer to you. But for the time being, just assume that a strong inverted spin orbit coupling between nucleons is experienced by the nucleons when they are filled in various energy levels. So this particular spin orbit coupling, the energy of that, okay, so the potential, okay, the potential is proportional, the potential which they feel because of spin orbit coupling, the potential on account of spin orbit coupling is proportional to dot product of S and L. Okay, that is the thing. So in addition to nuclear potential, they also feel a inverted, okay, spin orbit interaction. So S dot L is the thing, the potential is proportional to S dot L. So they already feel the potential of nuclear force, and they are also feeling, along with this nuclear force potential, they are also feeling the potential of inverted spin orbit coupling. Okay, so the potential value is directly proportional to dot product of S and L vectors. Okay, what are these S vector, what is this S vector, what is this L vector? You have already learnt in the lower classes and also in the previous lectures of this particular series. You have already learnt them. Now, strong means that consequent splitting of energy levels into sub-levels is many times larger than analogous splitting of atomic energy levels. Now, in case of atomic energy levels, when the splitting takes place, what happens? When the splitting takes place in case of atomic energy levels, the difference is energy is of the order of electron volts. So let me tell you that whenever splitting takes place in case of atomic energy levels, the splitting is of the order of electron volts. Okay, but in case of nucleons, this was the case with electrons, right? So nucleus will have nucleons. So in case of nucleus, that is protons or neutrons, the splitting is of the order of kilo electron volts. Okay, or even higher. Okay, so that is what is the meaning of strong. Okay, so strong coupling, strong inverted SL coupling, spin orbit coupling, strong inverted spin orbit coupling means that consequent splitting of energy levels into sub levels is many times larger than analogous splitting of atomic energy levels. So the splitting of nuclear energy levels, is very, very strong coupling. Okay, very strong spin orbit inverted coupling. So the splitting is of the order of kilo electron volt instead of electron volt. So electron volt was for atomic energy levels, and for nuclear energy levels the splitting is of the order of kilo electron volt. Okay. So for atomic, let me repeat, for atomic energy levels the splitting is of the order of electron volt. The energy levels split in the order of electron volt due to coupling. But in case of nuclear energy levels, the splitting is of the order of kilo electron volts because of inverted spin orbit coupling. And what is this inverted spin orbit coupling? We are going to learn in atomic and molecular physics in very much detail that what is this inverted spin orbit coupling. We are going to learn in atomic and molecular physics in very much detail. So for the time being, just do not lose control on yourself that I haven't learned this, so how can I study. So you need not worry. I am going to teach each and everything in the atomic and molecular physics series, which is going to come very soon. Okay, so that is the thing. Inverted means that energy of the nucleon is decreased when S dot L is positive. Okay, when the value of S dot L, that is why it is being called as inverted spin orbit coupling. Okay, we have written here over here, right? We have written over here strong inverted spin orbit coupling. Okay, strong, I have already told you the meaning of strong. Now inverted spin orbit coupling, what does it mean? So the meaning of inverted spin orbit coupling is that the energy of the nucleon is decreased. Okay, inverted means when this S dot L is positive, then the energy of nucleon is decreased, and when S dot L is negative, the value of the energy of nucleon is increased. Okay, so energy of nucleon is increased when S dot L is negative, then the energy of nucleon is increased when S dot L is negative, and when S dot L is positive, the energy of nucleon is decreased. Okay, that is the thing. ELS equal to minus alpha L dot S, that is inverted LS coupling. Okay, now dot product is commutative, that's why L has been written first, S has been written afterwards, so doesn't matter. Okay, so ELS equal to minus alpha L dot S. Now you know this very well that it will be minus alpha LS. Okay, because cos theta will also be there, but the angle between them is 0. So what will happen? Minus alpha LS will be the thing which we get, because cos 0 is 1, right? So minus alpha LS is the value. Now for any nucleon, what will happen? For any nucleon, L equal to J equal to L plus half or L minus half. I have already told you, right? Whenever the splitting takes place, the lower energy level has J equal to L plus half, and the higher energy level has J equal to L minus half. I have already told you. And when L equal to 0, then what will happen? Only one value is possible in case of L equal to 0. L equal to 0 is an exception. When L equal to 0, no splitting takes place. Okay, so only one value of J is possible in case of L equal to 0. So in case of L equal to 0, J value will be equal to half only, not minus half, because J cannot be negative. Okay, so that is the thing. Now ELS equal to minus alpha dash L. Now what is this? Let us understand this particular fact. Okay, what is the meaning of these statements and how did we arise at them? How did we arise at these expressions? We are going to learn about it now. Okay, so from here, as already told to you, it is a minus alpha LS. Okay, so dot product is scalar, so it will be minus alpha LS. Now and the angle between them is 0, so cos theta equal to will be equal to 1 because theta is 0. I have already told you. Okay, now we know this very well that the value of S is what? Value of S is only half, right? Value of S is only half. So let us write alpha into half as another constant equal to alpha dash. Let us write that. So it will be equal to minus alpha dash L. Okay, it will be equal to like that. Now you know this very well, that the energy for lower J value, okay. Now when you can see this expression is matching with this particular expression, right? With this particular expression, this expression is matching. So for L plus half, that will be equal to minus alpha dash L, and when L minus half, the value will be L minus half. So what will happen? You can see over here that when I write alpha dash L plus half, then what will happen? It will be equal to minus alpha dash L plus half alpha dash, okay. So half alpha dash, let me see properly, just a second friends. So just a second friends, just a second, whether I have done some mistake over here in writing or not, I have to see, just a second, okay. J equal to so let us see minus alpha ls was the thing which we had with us. Now minus alpha, when we have L plus half, then what will happen? It will be like this, okay, into S. Now you can write this to be minus alpha L S, okay, minus alpha by 2 S, right? You can write it like this. Now when you can write it like this, so what will happen? You can write the expression to be alpha dash L, okay. You can assume one new constant alpha dash, and you can assign this value as alpha dash L, because this is a constant, okay. Because S is constant, alpha is constant, so this value is constant, and this particular value of S is also a constant, so only L is variable over here, so you can assume it to be minus alpha dash L. And when L will be equal to L minus half, then you can put the value as L plus 1. Why? Because the difference between these two levels is 1, okay. L plus half and L minus half, what is the difference between L plus half and L minus half? You can see it to be equal to 1 clearly, okay. So that's why L plus 1 has been written. We are assuming L plus half to be equal to L, and we are assuming we are writing L minus half then to be equal to L plus 1, okay. So that is the thing, because the energy will be higher, when energy will be lower when J is J is higher, okay. So the energy for this is what? This is lower J, so the energy is lower, okay, because negative sign is there. So when more quantity has negative sign, then that is called lower level, okay. So when J is lower, then what? This value of energy is lower, okay. And when J is higher, what will happen? This value is higher, okay. So you can understand it. This is just mathematical manipulations, okay. These are just mathematical manipulations, okay. You can yourself do all these things. So you can see over here that actually the splitting takes place in this manner, that the lower value of J is upwards and higher value of J is downwards, okay. So the higher value of J has lower energy, you can see over here, okay. Higher energy, sorry, okay. Higher value of J has lower energy, yes, right. And lower value of J has higher energy, you can see over here clearly, okay. So that is the thing. Why higher energy? Although it is a negative sign, but lower value of J is higher over here, you can see over here, okay. Lower value of J is at higher level, higher value of J is at lower level, okay. Energy is increasing over here. So lower value of J is in the higher position, that is higher energy, and higher value of J is in the lower position. Okay, so higher value of J has lower energy and lower value of J has higher energy. Okay, it is also written over here. Okay, it is also written over here, you can see it is also written over here. Okay, so that is the thing. Now, nuclear spin orbit interaction is not magnetic in nature. Okay, nuclear spin orbit interaction is not magnetic in nature and is rather an attribute of nuclear force. Okay, the nuclear spin orbit interaction is not magnetic in nature. This thing you must remember. Okay, because in case of electrons, it is the magnetic. There is no magnetic splitting taking place over here. Okay, there is no magnetic splitting taking place. There is no magnetic splitting which is taking place over here. Okay, this thing you must remember. On the other hand, the nuclear spin orbit interaction is an attribute of nuclear force. Okay, the spin orbit coupling can be either LS coupling or JJ coupling. I have already told to you there are two types of coupling possible, either LS coupling or JJ coupling. So spin orbit coupling can be either LS coupling or JJ. LS coupling holds for very light nuclei, whereas JJ coupling holds for heavier nuclei. I had already told to you this particular fact also. If not told, then I am telling you now that LS coupling holds for very light nuclei, and whereas JJ coupling will hold for very heavier nucleus. Okay, and what is the difference between LS coupling and JJ coupling? I have already told to you in the previous lectures. If you haven't watched them, then you can certainly go to the link in the description and you can start watching from the very first lecture. You will understand each and every concept very clearly then. Okay. So nuclear spin orbit interaction is not magnetic in nature, rather it is an attribute of nuclear force. So there is no magnetic splitting taking place over here. The spin orbit coupling can be either LS coupling or JJ coupling. The spin orbit coupling can be what? It can be either LS coupling or it can be JJ coupling. LS coupling holds for very light nuclei, whereas JJ coupling holds for heavier nuclei. So it is JJ coupling which holds for great majority of nuclei. Okay. So because the lighter nuclei are very few, so JJ coupling will hold for a great majority of nuclei. Okay. As a result of the spin orbit interaction, the energies of split levels depend on quantum number J. From here onwards, we will look in the next segment. Okay, from the 6th point onwards, we will look in the next segment. So, in this particular video itself, I am merging the next segment, so you can watch it. Okay, from the 6th point onwards, we will discuss there. So as a result of spin orbit interaction, the energies of the split level depends on quantum number J as well as N and L. So I have already told to you that the energies of split levels depend on quantum number J as well as N and L. So according to exclusion principle, each of these levels, okay, has a capacity of 2J plus 1. So each level has a capacity of 2J plus 1. Okay, so whatever will be the value of J for a particular subshell, whatever will be the value of J, so your capacity of that particular shell will be 2J plus 1, and that is the number of possible values of Mj. Okay, you can look at the similarity with electrons. Okay, you can look at the similarity with electrons over here. Okay, you have already seen that when electrons are filled like this, okay, 1 2 3 4 5, what happens? The total values of ml possible, those are what? This will be -1, this will be this will be -2, this will be -1, this will be 0, +1 and +2, like that. Okay, so what will happen? The possible values of ml, total possible values of ml are what? 5. 1 2 3 4 5 5 values of ml are possible in case of electrons, I am saying. Okay, so I am giving you the analogy with electrons, and the total number of electrons which can be filled, that is given by what? Okay, so this is D subshell. So D subshell is there, and what is the value of L for D subshell? That is equal to 2. Okay, so 2 into 2L plus 1 is the total number. Okay, so what will be that? 2. When you put L equal to 2 over here, you get equal to 10. Okay, so 10 electrons can be filled over here, right? So similarly for nucleons, we have 2j plus 1. The value depends on j. Okay, so each level has a capacity 2j plus 1, which is equal to the total possible number of values of mj. Okay, so that is the thing. You will understand it when we give the examples. Now figure below, that is below means on the next page. Okay, below means on the next page. Figure below shows the nucleon energy levels according to the shell model. So various nucleon energy levels are being shown over here according to the shell model. The levels are designated by a prefix equal to the total quantum number n. Okay, so prefix is what? Prefix over here, the 1, 2, 3, 2, 4, 3, 5, etc. What are these? These are your quantum number n, that is principal quantum number n. A letter that indicates L for each particle in that level. Okay, now a letter that indicates L means, a letter means S, P, D. Okay, so L equal to 0 represents S, L equal to 1 represents P, L equal to 2 represents D. Okay, L equal to 3 represents F, right? L equal to 4 represents G, right? So like that. A letter that indicates L, so S, P, D, F are the letters that are there for various levels, various values of L. Okay, for each particle in that level, and a subscript equal to J. And subscript equal to J means the subscript that are written over here. Okay, subscript you can see. Let me put this to the upward side. Okay, so the subscript you can see over here. 1 by 2 is the value of j, 3 by 2 is the value of j, 1 by 2 is the value of j, 5 by 2 is the value of j, 1 by 2 is the value of j, 3 by 2 is the value of j, 7 by 2 is the value of j, similarly 9 by 2 is the value of j, 7 by 2 is the value of j, like that. Okay. So let me put this yet upward. Okay, a subscript equal to j. The spin orbit interaction splits each state of given j into 2j plus 1 substates. Okay, so there the spin orbit interaction splits each of them to further 2j plus 1 states. Okay, so you can see over here the spin orbit interaction has splitted these levels. Okay, the spin orbit interaction splits each state of given j into 2j plus 1 substates. Okay, so there are actually each substate has a electron, right? So you can see over here the value of j, for look at this particular case, the value of j is equal to what? 3 by 2. Okay, now the total values of mj possible, that is possible, it will be 2j plus 1. Okay, so that will be 2 into 3 by 2 plus 1, that is equal to 4. So total values of mj is equal to the total number of electrons it can hold, that is 4. So it can hold 4 electrons. Okay, so 2j plus 1 is the total number of electrons it can hold and the total number of mj values. Okay, so this 2j plus 1 also represents the total number of mj values, mj quantum number values. Okay, mj values. You have already seen this in the previous slide also, that capacity of 2j plus 1, that is total possible values of mj. Okay, so that is the thing. So there are 2j plus 1 substates over here. We have not shown the substates. Okay, please note that there are 2j plus 1 splittings over here, 2j plus 1 splittings over here, 2j plus 1 splittings over here, which we have not shown. Okay, so how much splittings will be there? Here will be 2j plus 1 means 2 splittings over here. Okay, so each splitting will have 1 electron. So there are 2 electrons. There will be 4 splittings, 2j plus 1 equal to 4. So 4 splittings over here. So 4 mj values possible. So each mj value will have 1 electron. So there are 4, not electron, nucleon. Okay, so there are 4 nucleons over here. Okay, so sorry, I might have said electron somewhere, but we are talking about nucleon. Okay, so please remember that. So there are 2j plus 1 splittings, that is 2 splittings. Okay, so each splitting will have 1 nucleon. So there are 2 nucleon. Then we will have 4 splittings, 2j plus 1, that is mj values possible are 4. Each mj value will have 1 nucleon. Okay, so there are 4 nucleons. Then 2 nucleons possible, because 2 splittings, 2j plus 1 equal to 2. So 2 nucleons might be there and 2 mj values possible. So 2 nucleons will be there. Then 6 similarly like that. Okay, so we have such the situation. The spin orbit interaction splits each state of given j into 2j plus 1 substrate. The accumulated population of nucleons correspond to a magic number at every one of the larger energy gaps. Okay, so accumulated possible population of nucleons correspond to magic number at every one of the larger energy gaps. So let me tell you that the energy gap over here is huge. 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 Okay, but it is appearing not to be huge over here because I have drawn the figure a little bit like that because I had a very low space. Okay, but over here the energy gap is higher, very high. Whenever there will be a very high energy gap, then the shell changes. This is the first shell. Okay, so it has 2 nucleons. Then this is the second shell. These two together form the second shell. These 3 together form the third shell. These alone forms the fourth shell. These all together forms the fifth shell. Then these all together form the sixth shell. These all together form the seventh shell. Okay, so such is the situation with us. Okay, so neutrons and protons will be filled separately. Okay, the accumulated population of nucleons correspond to a magic number at every one of the larger energy gaps. So you can clearly see over here the shell number is changing, so huge energy gap, so magic number 2. Over here the shell number will change because of huge energy gap, so magic number 8. Over here the gap is huge. Okay, as the gap is huge, so the shell number will change. Okay, so the shell number will change, so the magic number 20. Over here the energy gap is huge. Okay, this alone is a shell. This alone is a shell. Please remember this fact. Okay, so over here also the energy gap will be huge, so we have encountered another magic number 28. Then over here also the magic number will be encountered because the energy gap between another level of this one will be huge. So over here also we encountered magic number 50. Then I have rewritten this on the next page because of lack of space, so rewritten that. So over here when we see this, the energy gap between the below one was this. Okay, so energy gap was huge, so the next shell we encountered, and as soon as we encountered the next shell we got the magic number 50. Then over here the energy gap will be huge because these together form one shell and huge energy difference. Then the next shell starts. Okay, so because of the huge energy difference we will encounter another magic number over here. Then this is one shell, so I encountered one more magic number. Then after this no more elements have been discovered. Okay, after this no more elements have been discovered, so that's why no need to go beyond this. This is the last. So 126 number of protons is the last case. Okay, 126 number of protons is the last case. No need to go beyond this. Okay, no one is going to ask you beyond this. Beyond this also there will exist, because when we have 120 protons, what do we have then? When we have 120 protons, then we have 226 neutrons with us. Okay, so the 226 neutrons will be filled beyond this, right? So no need to go beyond this because no one is going to ask you energy shell diagram beyond 126. No one is going to ask. Okay, so please remember this much only. So where we were? So we were over here. The accumulated population of nucleons correspond to magic number at every one of the larger energy gaps. Hence shells are filled when there are 2, 8, 20, 28, 50, 82 and 126 neutrons or protons in the nucleus. So these are what matching numbers. So shells are completely filled when there are 2, 8, 20, 28, 50, 82 and 126 neutrons or protons in the nucleus. Shells are completely filled, so they are magic numbers, so there is extra stability in such nuclei. Okay, so such is the situation. Now how to remember? Now let me tell you the meaning of this. Okay, let me tell you the meaning of this. This is a trick. This is a trick to draw the energy level diagram. This is what? This is a part of trick to draw the energy level diagram. Okay, so let us see the trick. So 1s will be the starting, there is no doubt about it. Okay, 1s will be the starting, there is no doubt about it. So 1s will not undergo splitting. Okay, you know this very well that for S subshell has L equal to 0, and for L equal to 0 there is no splitting. so only one energy level. Okay, so it will have only one J value, J equal to half. So 2J plus 1 number of nucleons, so 2J plus 1 is equal to 2. Okay, 2 into half plus 1, that will be equal to 2. So total number of nucleons is 2. Now we have encountered magic number 2, so there will be next shell starting, because we have already encountered magic number 2. So this alone will be one shell, 1s will be alone one shell in itself. Okay, so we will encounter another shell now, we will encounter another shell. But what will be the number which we give? So this was first shell, so we will give 2 number. Okay, forget about these things for the time being, forget about these numbers written in the side for the time being. Okay, forget about this for the time being, for the time being I am saying. Okay, so forget about this for the time being. First let me tell you this particular convention, then I will also tell you regarding this particular convention. Okay, so after 1s what should we write? So this particular thing shows the trick. Okay, after s there is p. Okay, so see, spuds if pug. Okay, spuds if pig dish of pig. Okay, so remember this, spuds if pig dish of pig. Okay, so delete all the vowels over here. So what are vowels? Vowels are a, e, I, o and u. These are what? These are vowels. So whenever you encounter a vowel over here, just delete that. So spuds, so delete u, because u is a vowel, so delete it. If I is a vowel, so delete it. Pig, I is a vowel, so delete it. Dish, I is a vowel, so delete it. Of, o is a vowel, so delete it. Pig, now there is I as a vowel over here, but delete all vowels except last. Okay, so the last vowel I will remain. Okay, so this vowel will remain, so that's why tick is there, and over here there are crosses. Okay, so that is the thing. Now the accumulated population of nuclei correspond to magic number at every one of the larger energy gaps, and numbers are like that. Okay, so this was already done. Now, so I was telling you the trick. So s was done, 1s was done. Now we will encounter p. Okay, after s there is p, so we have written p. Now we have already encountered the magic number 2, so that's why we are writing this to be second shell. Okay, so that is the thing, so it is 2p. Now after 2p will be split in two levels, like this. Okay, so p equal, so as the value of l equal to 1 for p, so 1 minus half and 1 plus half. 1 plus half is 3 by 2, 1 minus half is 1 by 2. Okay, so the lower level of j lies to the higher side. Okay, so 2j plus 1 will be equal to 4, 2j plus 1 will be equal to 2. Okay, 2 into half plus 1 is 2, 2 into 3 by 2 plus 1 is 4. So 4 plus 2 is 6 number of nucleons. Now you can see the total number of nucleons we have encountered till now is 2 plus 6, that is equal to 8. So that is the total number of nucleons which we have encountered. Now 8 is a magic number, so second shell is completely filled over here. Now after p what should we write? After p what should we write? After p we should write d. Okay, as shown in this trick. So first s then p, after p we should write d. So now the second shell is complete because we have encountered magic number. So what will happen? We will write 3d because we are talking about third shell. Okay, so the 3d will again split. 3d will again split into 2. Now for d has l equal to 2, right? So l equal to 2 plus, so 2 minus half and 2 plus half will be the values of j. Now 2 minus half is 3 by 2 and the 2 plus half is 5 by 2. So 5 by 2 will be lower, 3 by 2 will be higher. Okay, so that is the thing. Now please note that the another energy level 2s. Okay, so after d we are writing again s. So how we are writing again s? Let us see. After d s is there. Yes, after d s is there. So again s will come, but this time as 1s was already written, so we will write it to be 2s because 1 has already been occupied over here, so we will write 2s. Okay, so that is the thing. Now how to remember that this s, lies between these two, this s lies between these d's. How to remember that you have to remember through practice, Okay, so s will not split again because for s l equal to 0, so it will have only one value, half. Okay, so 2 into 5 by 2 plus 1, that is 6. 2 into 1 by 2 plus 1, that is 2. 2 into 3 by 2 plus 1, that is 4. So 6 nucleons, 2 nucleons, 4 nucleons. So that is total of 12 nucleons. Now when we count the total number of nucleons, 2 plus 6 plus 12, that is equal to 20. So 20 is the total number of nucleons that we have till now. So now 20 number of nucleons means we have encountered magic number. So the shell is complete. Okay. So these together will form one shell. Why? Because magic number encountered. These together will form one shell because magic number encountered. These alone will form one shell because magic number encountered. So that's how you can remember. Okay. Now we will move on towards the how many shells done. One shell, two shell, three shell. Now we are moving to fourth shell. Okay. So after S, what is the thing which we have to write? After S we have to write F. After S we have to write F. Okay. So let us see. Now we will write F. But we have moved on towards fourth shell. First, second, third, and fourth. So we will write 4F. We will write, that's why 4F. Okay. Now the 4F will be splitted in 2. Okay. So the value of F. What is the value of F? For the value for F, the value of L is equal to 3. Okay. So it will be split into 3 plus half and 3 minus half. Now 3 plus half. 3 plus half is what? 3 plus half is 7 by 2. Okay. And 3 minus half is 5 by 2. So that is the thing. Now this 3p will lie something like this. Okay. As shown in the figure. Now after F, what is the thing which we have to write? After F we have to write P. Okay. But after F we have to write P. But the P has already been encountered, that is 2p. So we will write it to be 3p instead of 4p. We will not write it to be 4p. We will write it 3p. Okay. So the 3p values, what will be the 3p values? The value of L for P is equal to 1. So 1 minus half, 1 plus half. So 1 minus half over here, 1 plus half over here. Okay. So that is the thing. Now this alone. Now when we write the number of nucleons for this particular case, that is 8. Now we have encountered magic number 28 over here. 20 plus 8. Okay, you can count this. That is equal to 28. Or you can complete the count like this also. 20 plus 8, 28. So total number of nucleons 28. That is magic number encountered. So that's why this alone will be a shell. This alone will be a shell. Now from here till here. Okay. No magic number encountered. So we will write the next shell. That is 5G. So after P we are getting G. How we are getting that? Through this trick. After P we are getting G through this trick. Okay. So G will again split into 2. But we have to encounter magic number. So we have encountered 28. So we will keep on giving this bracket until we get 50. So after you see this, you get 50. Okay. Now the value of L for G. What is the value of L for G? L is equal to 4 for G. So 4 minus half. 4 minus half will be 7 by 2. And 4 plus half will be 9 by 2. Okay. So that is the thing. So the 10 electrons, 2j plus 1, according to 2j plus 1, 10 electrons, 2 into 9 by 2 plus 1, that is 10, and 2 into 7 by 2 plus 1, that is 8. Okay. Now we have to encounter magic number. So up to here we have encountered magic number. So this particular thing will go in the next shell. Okay. So that is the thing. Now these up to here, that there are 22 number of nucleons. So 28 up to here it was 28. Now 28 plus 22, that will be 50. Again magic number encountered. Now this has been written on the next slide once again. Now you can see on the next slide once again we have written that, and 5G is there. So 2 into 7 by 2 plus 1. So that will be equal to 8. Now 4D. Okay. So 4D will be splitted again into 2. Now how we have got D? Because after G, you can see over here, after G we have got D. Okay. So we will write after G we have got D. After G we have got D. So it will be 4D. Why will it be 4D? Because this was 3D, right? So 3 has been already occupied. So after 3, immediate number is 4. So we will write it 4D. Okay. So 4D has again been splitted like this. So you can so on see the things. Okay. This is a very easy concept. So remember this thing, that the first shell will be named as 1, then the second shell will be named as 2. But from here onwards, whenever we encounter P once again, that will be named as 3. Okay. From here onwards, whenever S will be encountered once again, that will be named as 2. From here onwards, whenever D will be encountered once again, that will be named as 4. Okay. From here onwards, whenever F is encountered once again, that will be named as 5F. Okay, so that's how you have to see this. So by this particular trick, okay, by this particular trick, you can see this entire energy level diagram. There is no big deal in it. Now let me explain. Now forget these conventions. Now forget these particular conventions. Which conventions? Now forget these conventions. Okay. Now let me tell you about these particular conventions. The conventions over here. Okay, I am telling you regarding these. So there are two conventions to write. Now, according to this red convention, what is the thing? 1s. Then after s, what will be there? After s there will be p, right? After s there will be p. So after s there will be p. So this was 1s. So this will be 1p. Okay. Now why it will be 1p, not 2p? Because this is different convention, and according to this different convention, p has been encountered the first time. P has been encountered the first time, so 1p. Now D has been encountered the first time, so 1d. F has been encountered the first time, so 1f. Now P is being encountered second time, so that's why 2p. G has been encountered first time, so 1g. Okay. D has been encountered second time, okay, so 2d. Okay, because you can see over here D is already there, 1d, so that's why the second convention says 2d. Then H has been encountered first time, so 1h. F has been encountered first time, so 1f. Then P has been encountered the third time, so 3p. How third time? You can see 1, 1, 2, so this will be 3p. Okay. Now I has been encountered the second time, okay, so this will be 2i. How 2i? Because you can see over here I has been already encountered. Okay, I has been, no, not I, sorry, just let me see. Okay, no, F has been encountered the second time. Okay, F has been encountered first time over here, and F has been encountered second time over here. So this is not 1F, please forgive me, this is 2F. Okay, so please make that correction in your PDF. Okay, in your PDF means in your notes, that's what I mean. So how to fill up this, you have already learned this. Okay, but let me just repeat it for you. Let me just repeat it for you once again, so that you understand it in a better way. You can see over here we are talking about S. Then what will be there? We will start with 1s because the first shell. Okay, so that will not undergo splitting, you know this very well. So that will be, because L equal to 0 for S, and as L equal to 0 for S, so there will be no splitting, so only half value will be there. J equal to 1 by 2 will be the only possible value. So 1s 1 by 2, so that will encounter 2 electrons. Okay, that will occupy 2 nucleons. Then we have 2p. Then similarly that will be splitted into 2. Why? Because L equal to 1 for p, so L plus 1 plus half, 1 minus half, because L plus half, L minus half. L equal to 1, so 1 plus half, 1 minus half. 1 plus half is over here, 1 minus half is over here. Now 2j plus 1 will be the total number of nucleons, so the total number of nucleons is 6. Now 2 was magic number, so this was separate shell. Now 6 nucleons we have already done with, so 2 plus 6, that will be equal to 8, so 8 nucleons. So this again will be a complete shell. So similarly you can keep on going. So after P what will be write? Okay, so you can see over here after P we will write D. Okay, so in D what will happen? For D, L equal to 2, so 2 plus half, 2 minus half. 2 plus half is over here, 2 minus half is over here. Okay, then 2 into 5 by 2 plus 1, that will be equal to 6, 2j plus 1 number of nucleons, and 2 into 3 by 2 plus 1, 2j plus 1, that will be equal to 4 number of nucleons. Now 2s level lies over here. Now how we got that? We get S over there. So after D we have S. Okay, so 2s is over here. Now for S, L equal to 0, so only one J value is possible, that is 1 by 2. So 2s half, so again 2 electrons. Now how we got this 2s? How do we know that this 2s lies between 2 3D? Okay, between 2 3D subshells this 2s lies. How we get to know? this is experimentally determined. Okay, so as this is experimentally determined, so you have to remember, mug it up, that 2s lies like this. You have to mug this fact up. Okay, because this is experimentally determined. So 6, then 2 into half, 2 into 5 by 2 plus 1 6, 2 into 1 by 2 plus 1 2, 2 into 3 by 2 plus 1, that is 4. Now 6 plus 2 plus 4, that is equal to 12. Now we have already done with 2 plus 6, that is 8 electrons, 8 nucleons over here. Now there are 12 nucleons, so 8 plus 12, that will be equal to the 20 total number of nucleons. Okay, now 4f will be there. After s there is f. How we came to know? After s there is f. Okay, so there is f. Now for f, the value of l is what? For the value of l is 3 for f, right? The value of l equal to 3 for f. So 3 plus half, 3 minus half. So 3 plus half over here, 3 minus half over here. Now after f there will be p. Okay, how we came to know? After f there will be p. Okay, now the 3p lies like this and 4f lies like this. You have to do this by practice. Okay, now 4f 7 by 2, 7 by 2 plus 1, 2 into 7 by 2 plus 1, that will be equal to 8. Now we are done with 20 nucleons. Now 8 nucleons additional, so that will be 28 nucleons. So this will be in itself a complete shell, because 28 is a magic number. Okay, so similarly you can go on so on and so forth up to here. Okay, you can go on so on and so forth up to here, but I will tell you that also. Okay, so let me tell you that also. Now similarly 2 into 3 by 2 plus 1 4, 2 into 5 by 2 plus 1 6, 2 into 1 by 2 plus 1 2, 2 into 9 by 2 plus 1 10. Okay, now how we got g? You can see over here, after p there is g. Okay, so we got this g. Now up to here there will be one shell, because then 22 plus 22, because 28 plus 22 gives you 50, 28 plus 22 gives you 50, right? So that will be complete shell. So you can yourself draw this particular energy level diagram. Okay, there is no need of me telling you once again everything. Okay, so you can yourself do that. So thank you very much. Hopefully you have understood how to draw the energy level diagram. Okay, so thank you very much, and thanks for watching the video. So you can see over here that this 1s. Okay, so let me put this to the upward side, just a second. Yes, so I have successfully put that to the upward side. Now let us see. So after 1s there is 2p according to this. Okay, then there is d. Okay, so we will write 3d. Then we have s. So s has been encountered once again, so that will be 2s. After s there is f. Okay, so that will be 4f, because this is fourth shell, first, second, third, and then fourth. Okay, so that's why 4f. Then after that similarly p, but p has been repeated. Okay, 2p has already been done, so it will be written as 3p. Similarly, then after p what do we have? After p we have g, right? So after p we have g, but this is what? Fifth number shell. How fifth? 1 2 3 4. Okay, 1 2 3 4 5. Okay, so this is fifth shell, and this particular part 5g 9 by 2 is coming in the fifth shell. Okay, lower part of this, so that will be 5g, because fifth shell, lower part is constituting the fifth shell, that's why. So 5g. Then after g what do we have? After g we have d. So let us see. After g, this is 5g. After g we have d, but d has been encountered how many times? This is the 3d. Okay, so after 3d there will be 4d, right? So 4d is there. Then after d what do we have? After d we have s. Okay, so after d we have s. So let us see. After d we have s, but the s, 1s and 2s have already been done, so s will be written as 3s. Okay, then after s what do we have? After s we have h. Okay, so after s we have h, so after s we have h, but this will be 6h. Why will it be 6h? Because you can see over here that this is sixth shell. 1 2 3 4 5, and then this is 6th shell. So that's why the lower part of it is coming in the 6th shell, so it will be named as 6H. Okay, so after H what do we have then? After H we have F. Okay, so after H we have F. Now how many times we already had 4F, so we will write it to be 5F instead of 6F or 7F. Okay, so we will write it 5F because 4F has been done and in continuation to 4 there is 5, so that's why 5F has been written. Now after F we have P. After F we have P. So after F we will have P, but 3P has already been done over here, so it will be 4P instead of 7P. Okay, so it will be 4P. Now after P what is there? After P there is I. After P there is I. Now after P there is I, but this I will be 7I. Why will it be 7I? Because this is the 7th shell. How it is 7th shell? 1, 2, 3, 4, 5, then 6 and then 7. So it will be 7I. In that manner you have to name them. Okay, and what about the other convention? The other convention which has been written over here, over here, over here, over here, over here, over here. Okay, then on the next page the other convention has been written over here, over here, over here, over here and over here. The other convention has been written like that. So how to understand the other convention? Other convention does not include principal quantum number, that is shell number, nuclear shell number. So this other convention does not include nuclear shell number. Now let us understand the other convention. This is 1s, then after that 1s, according to this particular thing we have, after S we have P. Okay, so after S we have P, so this is the first P subshell. Okay, the P letter that is L equal to 1 has been encountered the first time, so that's why it will be 1P. Then D has been encountered the first time, so it will be 1D. And how D was encountered? D was encountered according to this rule. After P there is D. Okay, so that is the thing. Now after D what do we have? After D we have S. Okay, so according to that trick, after D we will have S. Now as we will have S, so it will be 2S. Why it will be 2S? Because 1S has been done already. So as 1S is done already, so it will be 2S, right? Because S is being encountered second time, so it will be 2S. Then after S what do we have? After S we have F. Okay, after S we have F. So after S we will have F, but this F is the first time. F is what? This F is being encountered first time, so it will be 1F. Okay, so then after F what do we have? We have P. Okay, so after F we have P, but this will be 2P. Why? Because first time P has already been encountered and this P is being encountered the second time, so it will be called 2P. Then after P we have G. Okay, after P we have G, so after P we will have G, but this will be named as 1G because G is being encountered the very first time. Okay, then after G we have D. So after G we have D, but it will be named as 2D. Why will it be named as 2D? Because one time D has already been done over here, so that will be 2D. Okay, then after D what do we have? After D we have S. So after D we have S. Now why it is named as 3S? Because 1S, 2S, so it will be naturally 3S because S is being encountered the third time. So the other convention will also tell it to be 3S. The normal convention is also 3S, the other convention is also 3S only. Okay, now after 3S we have 1H. How we have 1H? Because after S we have H. Okay, and H is being encountered the very first time. H is being encountered the very first time, so 1H. Then after H what do we have? After H we have F. Now after H we have F, so after H we have F. Now F is being encountered the second time, 1F has already been done, so this will be basically your 2F. Okay, according to other convention. And after F what do we have? After F we have P. Okay, so after F we have P, so after F we will have P, but this P has been done how many times? 1P, 2P, so it will be what? It will be naturally then 3P. Okay, then after 3p we have 1i. How do we get 1i? Because after p there is I, right? Last vowel was not deleted. Last vowel was containing I. So there will be I. Okay. So last vowel was containing I. So there is I. Now, but this I is for the very first time. So it will be 1i. I don't know whether it is visible or not, but 1i has been written over here. Okay. According to other convention, 1i has been written over here. Okay. So that is the thing, how you do the other convention. Now how the splitting takes place? How does splitting, how does it take place? For S we have, after having written all these numbers, after having written the orbitals, what do we do? After that we just see what is the value of L. So for S, L equal to 0. So for L equal to 0 there is only one value of J, that is half, 0 plus half. Okay, so J equal to 1 by 2. So total number of nucleons is 2J plus 1, that will be equal to 2. Now magic number 2 has been encountered. So this in itself will be one shell. Okay, so that is the thing. Then what do we have? Then we have P. For P, what do we have the value of L? L equal to 1 for P. So L equal to 1 for P. So 1 plus half and 1 minus half will be the two values. 1 plus half has been written over here, and 1 plus half is 3 by 2, 1 minus half is 1 by 2. So they have been written. So two values of J, 3 by 2 and 1 by 2. Now 2J plus 1 will be equal to 4. Now let us check. 2 plus 4, it is equal to C. So 6. So not a magic number. Okay. Then 2 into 1 by 2 plus 1, that is equal to 2. So 2 plus 4 plus 2, that is equal to 8. So this will be again a shell. Okay. So 8 number of nucleons. So this will be again a shell. Then 3D. Then how do we know that 3D and 2s lie nearby? How do we know that 3D and 2s lie nearby? By practice. By practice we know that, because that is an experimentally determined fact. There is no trick to remember how 3D lies, how 2s lies between 3D, how the 2s subshell lies between 3Ds. That is experimentally determined fact. Okay, and how this 4f lies between 3p and how this 3p lies between 4f, that is an experimentally determined fact. So you have to remember this particular fact by practice, with the help of practice. Okay. Now 3D we have already seen how 3D came. Now 3D for D, L equal to what? For D, L equal to 2. So for D, L equal to 2, so 2 plus half, that will be equal to 5 by 2, 2 minus half, that will be equal to 3 by 2, and 5 by 2 and 3 by 2 are the two things. So 2 into 5 by 2, the total number of nucleons will be 2 into 5 by 2 plus 1, that is 6, 2 into 3 by 2 plus 1, that is 4, and over here 2s will remain as it is, because for S, L equal to 0. For S, L equal to 0. So 2 into 0 plus half will be the only J value. So J equal to 1 by 2. Now J equal to 1 by 2. So for this 2J plus 1, for this 2J plus 1, for this 2J plus 1. So after that you get 6, 2 and 4. Now let us check. This plus this plus this plus this plus this plus this, that equal to magic number. Now this is magic number is encountered. So this shell will be complete. Okay, one shell in itself. Now there will be higher energy gap. How do we know that there is higher energy gap? Because we have encountered magic number, and magic number means complete shell. So this is third complete shell. We have encountered magic number. Now 4f. 4f will be splitted like this. 4f 7 by 2, 4f 5 by 2. Why will it be splitted like this? Because for f L equal to 3. So 3 plus half. 3 plus half is 7 by 2. So 3 plus half is 7 by 2, and 3 minus half is 5 by 2. So like that. Okay. Then after 4f we have 3p. How it came I already told to you. Then L equal to 1 for p. So L equal to 1 for p. So 1 plus half. So 1 plus half is written over here 3 by 2. 1 minus half has been written over here 1 by 2. Okay, so there are 8 nucleons in this. How? 2 into 7 by 2 plus 1, that is 8 nucleons. Now as soon as we see that there are 8 nucleons, so 20 up to here there were 20 nucleons and 8 nucleons in addition, so 28. So we have encountered once again magic number, and as we have encountered once again a magic number, so this in itself will be a complete shell. This in itself will be alone a complete shell. Okay, so 2 into 3 by 2 plus 1 4, 2 into 5 by 2 plus 1 6, 2 into 1 by 2 plus 1 2, 2 into 9 by 2 plus 1 10. Okay, so after adding these it is 22, and 28 up to here nucleons were 28. Now 22 nucleons were added, so 50 magic number encountered, and as soon as you encountered the magic number 50, this in itself will be a complete shell. Okay, up to here. But this shell also includes the upward 5G level. Okay, so for 5G what do we have? For 5G, for G we have L equal to what? S, P, D, F. For F, after F we have G. Okay, so L equal to 4 for G, right? So 4 plus half is 9 by 2, 4 minus half is 7 by 2. Okay, but over here, up to here we are encountering magic number. Okay, up to here we are encountering magic number. So that's why what will we do? This will go into the other shell and there will be huge energy difference between these. So 4 plus half, 4 plus half is 9 by 2, 4 minus half is 7 by 2. So 9 by 2 plus 2 into 9 by 2 plus 1, 10, and 2 into 7 by 2 plus 1, that is 8. Huge energy difference, magic number encountered. So there is, this will go into the other shell. Okay, so that is on the next page written once again. Okay, now that is the thing. Now after that, after 5G, how we encountered 4D, I have already told you. But L equal to what? For D, L equal to SPD, L equal to 2. Okay, for D the value of L is equal to 2. Okay, so 2 plus half is 5 by 2, 2 minus half, that is 3 by 2, right? So 5 by 2 is there, 3 by 2 is there. Now 2 into 5 by 2 plus 1, that is 6, 2 into 3 by 2 plus 1, that is 4. Okay, still magic number not encountered. Okay, so we will again go for the next energy level. Then for the next energy level, L equal to 0. So only plus half value is possible. J value only plus half possible. So plus half. 2 into 1 by 2 plus 1, that is equal to 2. Okay, again magic number not encountered yet. Okay, so what will we do? We will move on towards the next energy level, that is H. Now for H, what is the value of L for H? So up to 4. So L equal to 5 for H. Okay, so 5 plus half will be the lower value of J, and 5 minus half will be the higher energy level value J. Okay, so that will be equal to 11 by 2 and that will be equal to 9 by 2. Okay, so let us see. So we have seen 11 by 2 and we have seen 9 by 2. Now this energy level will come in this shell. Why? Because 2 into 11 by 2 plus 1, that is 12, and as soon as 12 nucleons are filled, this particular shell becomes one shell, because 50 plus 32, up to here we had 50 nucleons. Now 32 nucleons are over here, so 50 plus 32, that is 82. So total number of nucleons 82. So this is one complete shell. Okay, so there will be huge energy difference over here then. Okay, so 6H 9 by 2 will go into the another shell because magic number has been encountered. So 2 into 9 by 2 plus 1, that is 10. Okay, then what will happen? Then after 6H, what do we have? We have 5F. How? According to that trick. Okay, according to this particular trick, we have after F, after 6H, we have 5F. How? I have already told to you. Once again I am telling. Okay, after H we have F. Okay, so after H we have F. Now this will be 5F because 4F has already been encountered. Now for F, what is the value of L? SPDF. Okay, so L equal to 3 for F. Now 3 plus half is 7 by 2, 3 minus half is 5 by 2. Okay, so 7 by 2 and 5 by 2 are the two levels, two splitting levels. Then 2 into 7 by 2 plus 1, that is 8. 2 into 5 by 2 plus 1, that is 6. So still magic number not encountered. So we will go to the next level. After 5F, what do we have? According to that particular trick, after F we have P. Okay, so it will be 4P. Why 4P? Because 3P has already been done. 3P has already been done over here, you can see. So that's why it will be 4P. Okay, now for P, L equal to 1. Okay, for P, L equal to 1. So 1 plus half, 1 minus half. So 1 plus half is 3 by 2, 1 minus half is 1 by 2. So 3 by 2 and 1 by 2. Okay, so you can clearly see this thing, that 2 into 3 by 2 plus 1, that is 4. 2 into 1 by 2 plus 1, that is 2. Still magic number not encountered after calculating the total number of nucleons. Still magic number not encountered. Okay, so we will go to the next level. After P we have I. How do we have I after P? You can see in this trick. After P we have I. Okay, so after P we have I over there. After P we have I over there. So it will be 7I because this is 7th shell. Okay, that will be 7I because this is 7th shell. You can clearly see first shell, second shell, third shell, fourth shell, fifth shell, sixth shell. Okay, this is the 6th shell, this is 7th shell. So that will be 7I. Now for I, what is the value of L? SPDF G H I. Okay, So let me see, S, P, D, F, G, H, I. So 0, 1, 2, 3, 4, 5, 6. So L equal to 6 for 7I. Okay, so for I, L equal to 6. Now L equal to 6 for I. So what will be the values of J? 6 plus half, that will be equal to 13 by 2, and 6 minus half, that will be equal to 11 by 2. Okay, so we will have two levels. One is 13 by 2 and another will be 7I 11 by 2. 7I 11 by 2. That has not been shown over here. Why? Because this particular level will go into the 8th shell. This will go into the 8th shell. Why will it go to the 8th shell? Because up to here we are, when we calculate the total number of nucleons up to here I mean, so after that 82 plus 44 gives 126, which is magic number. So 7th shell is complete over here. Okay, so 126 magic number encountered, that's why. So 7I 11 by 2 has not been shown over here because it goes to the 8th shell, and as it goes to the 8th shell, it means that it will have even higher magic number than 126. Okay, so that is the thing. So that's how you have to look at the energy levels. Okay, so this is the complete discussion of today. Thank you very much, and keep watching our channel. Thank you very much.